Hello and welcome to Caspian's first video presentation for you, our prospective customers. We're delighted to have an opportunity to share with you today the Caspian story. Larry and I will give you a brief introduction and overview of the company. That'll be followed up by some very in-depth product demonstrations in our laboratory, and then we'll be back to give you a wrap-up and summary of what you've seen. I hope you enjoy the show.
Many companies are working to improve the infrastructure of the Internet. But Caspian Networks, based in San Jose, California, has a new product that dramatically improves what many say is the hardest part of the Internet to change, the core.
ATM had tremendous capabilities in terms of managing quality of service, whereas IP, which had much better signaling, didn't have that capability. And IP routers weren't scaling to meet the need. The Moore's Law was controlling the rate of growth, and the routers were not growing as fast as the traffic.
If anyone knows the Internet and its limitations, it's Roberts. Roberts was one of 4 original pioneers of the Internet in the 60s. Roberts founded Caspian to build a new product to solve the problems of IP service quality and scale. Now, after 4 years in development, the company's product Apeiro, a Greek word for infinity, is available.
Apeiro is a unique class of product in that it fundamentally changes the rules of the game. It allows customers to consider new ways of architecting their Internet infrastructure.
Krauss is a networking veteran, one of the people who helped make Ethernet a household name as co-founder and CEO of 3Com. So when he came out of retirement to lead Caspian Networks, people noticed.
I'm just absolutely ecstatic to be here at Caspian. Caspian is such an exciting place to be for the reasons of having a tremendous market opportunity. We've got great people and a great product, and we're about to launch into the marketplace.
Inside Caspian's San Jose lab is where engineers have been busy for 3 years, working closely with leading service providers on the design of the product. Close up, Caspian's Apeiro looks much like a conventional router. However, product managers are quick to describe what makes it so revolutionary.
Apeiro really delivers 3 fundamental benefits for carriers. First, it allows them to reduce the amount of equipment they need in the core. Apeiro does this through its compact shelf design, multi-shelf scalability, and unique new features. Second, Apeiro keeps network costs predictable. Apeiro scales from small systems to large systems linearly. And third, Apeiro is the first IP system to deliver ATM-like quality of service for IP core networks.
And we do that by having an architecture that is based on 2 key design principles. First is distribution, and that enables multi-plane scalability and multi-plane availability. And second is flow state-based switching technology, and that allows very granular and deterministic quality of service, switching efficiency, and opens up the door for new applications.
Caspian's so-called flow state intelligence is a major architectural breakthrough, the company says. Unlike traditional core routers, Caspian's Apeiro can route the initial packets of individual microflows and switch subsequent packets of the flow. The result? High degrees of traffic control, determinism, network efficiency, and cost savings.
We decided in Caspian to build a switch that worked with the microflow and manage the quality of service for that flow so that we could manage the jitter and the bandwidth guarantees required for that flow. In order to do that, we need to remember the first packet goes by and then manage all the other packets according to that same destination and that same quality of service. No one has ever tried to do that before.
Apeiro's other fundamental difference is hardware and software distribution. Like a supercomputer, all capabilities of the Apeiro system grow as cards are added. This means no internal bottlenecks, making it easy to grow from very small systems to very large. It also makes Apeiro reliable because software and hardware are both distributed redundantly throughout the system. In other words, no single point of failure.
In order to have a system that would scale smoothly from a single card up to a very large number of cards, maybe 1,000 or 10,000, we needed to be able to build it like the Internet. Lots of machines talking to each other, exploring the paths with each other, and growing with the capacity of the traffic and monitoring the load on that path.
So how do these architectures translate into product capabilities? Caspian introduces us to Apeiro.
This is the Apeiro shelf. It's 120 gigabits per second, full duplex I/O per shelf. 3 shelves can be connected together in a 7-foot rack to get 360 gigabits per second full duplex I/O. Each shelf has 17 slots, 12 I/O slots. Each shelf is 24 inches high, 19 inches wide, 27 inches deep. It has 4 types of cards. It has your application processor cards, which run your routing protocols and are in warm standby right now. It has your half-height shelf supervisory cards, which are management cards that are in hot standby right now. It has 4 fabric cards in the center of the shelf that provide fabric connectivity. It also has your 12 I/O cards. Take a look at the I/O cards. As you can see, cards are hot swappable. It has 3 custom ASICs, 2 packet processing ASICs, and a store and forward ASIC. The packet processing ASICs are responsible for all the flow processing that happens in the system. All cards are accessible from the front, and maintenance actions don't disturb the I/O cabling.
Scalability is one of the most important characteristics of the system. It's been designed in the hardware and the software from the ground up. One could look at scalability from 4 different perspectives: the switching, the forwarding, management, and routing. In terms of switching and forwarding, the principle here is to incrementally add switching capacity, dynamically discover it, and use it as efficiently as possible. So one can start from a small shelf like this one, then expand to multiple shelves, then onto multiple racks using optical fabric interconnects. In terms of management, it's a linear scaling model, so you will be adding processing power and storage capacity whenever you add in shelves. In terms of routing scalability, routing is inherently centralized, so it will be running on an application processor. And then at some point, you may want to add additional processing power so you can have additional application processors. And there are partitioning approaches in the various routing protocols like BGP, OSPF, ISIS, and MPLS that allows them to make use of the distributed processing capabilities.
Apeiro is the first IP system to offer per-flow QoS, which enables ATM-like service differentiation for the IP core. This really allows carriers to offer predictable and bounded delay and delay variation for premium traffic, even under high load conditions. It also brings a circuit feel to the IP networks, thus combining the best of the circuit world and the packet world. All this with remaining interoperable with existing approaches, such as DiffServ.
Reliability is another very important characteristic of the system, and it's been designed in a software and hardware architecture since the very, very early stages. Again, one can look at it from 4 different perspectives: the switching, the forwarding, management, and routing. So in terms of switching and forwarding availability, the internal intelligence of the switch allows you to use the remaining available capacity as efficiently as possible. So if I pull a fabric card here, you will see very negligible impact on traffic flowing between the different line cards. In terms of management availability, the model is based on synchronizing states between the active and the standby management cards. So all the state is synchronized. So for example, if I pull the active management cards, like here, all the state is being kept on the standby one, and you will see 0 impact on the services running over a switch. In terms of routing availability, the principle is to selectively synchronize state information between the active and the standby. And here again, if I pull the active application processor card that's running all the routing protocols, the standby automatically takes over, and there is 0 impact on the traffic being forwarded. You've seen that I've pulled 3 cards here: the management card, the fabric card, and the application processor card, and the switch is still operational, and there is 0 impact on the traffic.
Another unique differentiator is the logical router feature. Logical routers allow multiple routers to be deployed in a single Apeiro platform. As you see here, we have 2 logical routers in this shelf: a pair of APs belonging to one logical router and a pair of APs belonging to another logical router. Logical routers really allow carriers to consolidate their networks and reduce cost of interconnects as well as expensive platforms.
Another unique feature of the Caspian platform is the ability to extend the switching fabric in a way that allows you to have multiple shelves in different geographical locations while acting as one single switch. For example, you have these 2 shelves in the same location here. By extending the switching fabric, you can have this shelf be in a totally different geographical location, and both of them acting as one switch. The benefit of this is it allows service providers to simplify networks and reduce costs. Interoperability is what you would need to fit into any network day one. Because of that, we've been working over the last couple of years with a number of carriers to validate the interoperability of the various routing protocols.
So here we have a live test bed with Juniper and Cisco and Caspian interoperating fully over a number of different protocols: ISIS, OSPF, BGP, and MPLS. It's critical for Caspian that interoperability be proven so that carriers can take advantage of Caspian's true differentiators while seamlessly integrating Apeiro into the IP networks.
CEO Bill Krause maintains Caspian's Apeiro is in a class of its own, the first product to cost-effectively offer deterministic quality of service over IP. Traditional core IP routers, he says, have limited cost-effectiveness due to poor scalability and low enforceable service guarantees. Multi-service switches offer high levels of service determinism, but low scalability, and therefore low cost-effectiveness. A new breed of scalable IP routers are more cost-effective, but still only offer the limited service guarantees inherent to DiffServ. Caspian says Apeiro is the first product to offer QoS capabilities equivalent to ATM, yet scale as large or as small as needed. The people at Caspian have opportunities to unwind. Fun work, according to CEO Krause, is just as important as smart work, teamwork, and, of course, a lot of hard work. And by all counts, Caspian is a company that works extraordinarily hard and closely with its customers.
One of the very important tenets of Caspian is our commitment to customer satisfaction, second to none. And in that regard, we work very closely with our customers in the development of our product. In fact, all of our product development investments are driven and guided by feedback from our customers. We've been working with a number of customers for over a period of 2 years.
With an ambitious vision, Krause at the helm, the innovative designs of Lawrence Roberts, and its initial product now available, Caspian stands on the verge of great things. After years of work, employees have a lot to be proud of. As to making inroads in the competitive core router marketplace, Caspian has what many now believe is a pretty good shot.